In 1944, the United States Navy faced a deadly enemy that possessed no weapons, but held absolutely infinite destructive power. Admiral Halsey watched helplessly as Typhoon Cobra destroyed his mighty Third Fleet, causing an unprecedented historical tragedy with massive casualties. 3 heavily armed destroyers capsized and sank beneath the violent waves, claiming the lives of 790 brave sailors. The terrifying storm completely ripped apart the steel superstructures, tossing massive ships around like tiny, fragile wooden bathtub toys. Amidst this absolute chaos, a young naval officer named Gerald Ford faced a truly horrifying near-death survival experience on board. A monstrous wave suddenly crashed over the flight deck, merely sweeping the future American president into the dark, freezing ocean. He desperately clung onto the narrow metal catwalk, dangling perilously above the churning black abyss of certain watery death below. This devastating historical event forced naval engineers to completely rethink how massive warships could withstand extreme oceanic weather conditions safely. To understand this incredible engineering challenge, we must first comprehend the sheer destructive power of a modern super typhoon storm. These monstrous atmospheric beasts generate sustained winds exceeding 240 kilometers per hour, tearing apart anything in their path. The ocean's surface transforms into a chaotic nightmare, with towering rogue waves reaching 18 meters high, crashing down with fury. A single 18-meter wave contains thousands of tons of crushing water, capable of snapping a smaller vessel in half. Modern aircraft carriers are essentially floating cities, housing 5,000 souls and carrying billions of dollars in advanced military hardware. Protecting these massive investments requires brilliant structural engineering and completely flawless operational procedures when facing the wrath of Mother Nature. The modern Nimitz and Ford-class carriers feature incredibly sophisticated hull designs specifically engineered to maximize stability during severe weather. Their massive weight is concentrated deep below the waterline, creating an exceptionally low center of gravity for maximum upright stability. This low center of gravity generates a powerful righting moment, which constantly pulls the massive ship back to level position. Even when struck by massive broadside waves, the carrier naturally resists rolling over and aggressively snaps back into upright alignment. The wide flight deck also acts like a giant stabilizer, preventing the hull from tipping too far during extreme rolls. Below the surface, massive active stabilizer fins can be deployed to counteract the violent rolling motion caused by storm surges. These computerized fins automatically adjust their angle every second, slicing through the water to keep the enormous vessel perfectly steady. Watertight compartments throughout the lower decks ensure that even if the hull breaches, the ship will remain safely afloat. Heavy steel armor plating protects the vital internal components from the crushing hydrostatic pressure exerted by massive ocean storm waves. The ship bow is specially shaped to slice through towering waves rather than slamming flat against the solid water walls. This aerodynamic and hydrodynamic design allows the 100,000-ton behemoth to maintain forward momentum despite the raging tempest. Advanced propulsion systems utilizing dual nuclear reactors provide virtually unlimited power to push through the most violent ocean currents imaginable. 4 massive bronze propellers bite into the water with incredible force, ensuring the ship never loses steering control during storms. Maintaining steering control is absolutely critical because turning sideways to the waves could expose the ship to catastrophic rolling forces. The captain must always keep the bow pointed directly into the oncoming waves to slice through them safely and efficiently. Navigating through a super typhoon requires incredible skill as the helmsman constantly battles the surging ocean to maintain proper heading.
The massive rudder responds instantly to steering commands, redirecting thousands of tons of water to keep the bow perfectly aligned. Even with all these advanced engineering marvels, the crew must perform rigorous preparations before the storm actually hits the fleet. This intense preparation phase is known as battening down the hatches, and it requires absolute perfection from every single sailor. The very first priority is securing the multi-million-dollar fighter jets currently parked on the exposed upper flight deck. Leaving aircraft exposed to 200-kilometer winds would result in them being blown straight off the deck into oblivion. Deck crews work frantically to move every single aircraft onto the massive hydraulic elevators for transport down into the hangar. These enormous elevators lower the heavy jets down into the cavernous internal hangar bay, where they are safe from winds. Once inside the hangar, deck crews use heavy steel chains to securely tie down each aircraft to reinforced deck pads. They attach up to 20 separate chains to a single fighter jet, ensuring it cannot move a single inch laterally. Every piece of loose equipment on the entire ship must be strapped down, bolted tight, or stored in locked cabinets. A single loose toolbox flying through the air during a violent ship roll becomes a deadly projectile capable of killing. Heavy steel doors on the exterior of the hull are slammed shut and locked tight with massive steel locking mechanisms. Rubber gaskets around every door compress tightly, creating a completely waterproof and airtight seal against the raging ocean storm outside. The entire aircraft carrier effectively transforms into a massive, sealed steel box, completely isolated from the violent atmospheric chaos outside. You might wonder why these massive ships do not simply stay safely docked inside a protected harbor during a typhoon. Surprisingly, remaining tied to a concrete pier is actually the most dangerous place for an aircraft carrier during a storm. The rising storm surge and violent winds would repeatedly smash the massive steel hull against the unforgiving solid concrete docks. Heavy mooring lines would snap under the extreme tension, turning the uncontrollable warship into a massive, destructive, floating wrecking ball. Therefore, standard naval doctrine dictates that the safest place for a ship during a massive storm is the open ocean.
Out in the deep water, the carrier has plenty of room to maneuver and ride out the massive ocean swells. The absolute best strategy for surviving a super typhoon is simply avoiding its destructive path in the very first place. This is where the Joint Typhoon Warning Center comes into play, providing critical meteorological intelligence to the entire naval fleet. Utilizing advanced weather satellites and radar systems, the center constantly monitors the formation and trajectory of dangerous tropical cyclone systems. Meteorologists analyze massive amounts of atmospheric data to predict exactly where the storm will move over the next several days. They transmit these detailed weather forecasts directly to the carrier strike group commander, allowing them to plan safe evasion routes. The fleet commander will order the ships to alter their course, steering hundreds of miles away from the predicted danger. This constant game of oceanic cat and mouse ensures the fleet remains fully operational while avoiding the worst weather conditions. But weather forecasting is never perfectly accurate, and storms can suddenly change direction, trapping the fleet in a dangerous position. When evasion fails and the storm strikes, the crew must prepare for the absolute worst-case scenarios inside the ship. The hangar bay becomes the most critical area of concern as millions of pounds of machinery are packed tightly together. If the ship rolls too violently, the immense strain on the heavy steel tie-down chains can reach breaking point. When a single chain snaps under the massive pressure, it creates a terrifying chain reaction of absolute destruction and chaos. A 30-ton fighter jet breaking loose inside the hangar bay transforms into an unstoppable metal beast, crushing everything nearby. The loose aircraft slides across the slick steel deck,
smashing violently into other parked jets and rupturing their fuel tanks. Highly flammable aviation fuel spills across the deck, mixing with electrical sparks from the crushed machinery to ignite massive fires. This nightmare scenario is exactly what happened during several historical naval disasters, resulting in massive explosions and tragic crew fatalities. To prevent this, modern hangar bays are equipped with advanced automated fire suppression systems capable of flooding the entire deck. Massive overhead nozzles can spray thousands of gallons of thick chemical foam, instantly smothering any potential fuel fires from spreading. Heavy steel blast doors can drop down from the ceiling, dividing the hangar bay into separate, isolated fire containment zones. Damage control teams stand ready in heavy fireproof suits, prepared to rush into the blazing inferno and save their ship.
These brave sailors train relentlessly for this exact moment, knowing that a massive, uncontrolled fire could sink the entire vessel. They carry heavy water hoses across the wildly pitching deck, fighting both the intense flames and the violent ship movements. The physical toll on the crew during these extreme storm conditions is absolutely immense and incredibly difficult to fully describe. Imagine trying to perform complex physical labor while standing inside a massive earthquake simulator that never stops shaking for days. The relentless, violent motion of the ship causes severe seasickness, even among the most hardened and experienced veteran naval sailors. Walking down a simple hallway becomes a dangerous athletic challenge as the floor constantly tilts violently from side to side. Sailors are thrown against steel bulkheads, suffering painful bruises and broken bones as the massive ship violently crashes through waves. Simple tasks like eating a meal or trying to sleep become completely impossible during the peak fury of the storm. Food trays slide off tables, crashing onto the deck, while exhausted sailors are repeatedly tossed completely out of their bunks. The deafening roar of the storm outside, combined with the groaning steel hull, creates an environment of constant psychological terror. Every massive wave strikes sounds like a bomb detonating against the hull, sending terrifying vibrations through the entire steel structure. The crew must endure this sensory overload for 12 to 24 hours straight, without any chance for proper rest. Fatigue becomes their greatest enemy, as exhausted minds struggle to remain focused on critical technical tasks and damage control procedures. The ship medical bay quickly fills up with injured and severely dehydrated sailors, requiring immediate attention from the medical staff. Doctors and corpsmen must perform emergency treatments while struggling to keep their own balance on the wildly unpredictable pitching deck. Down in the engineering spaces, the heat and noise are absolutely overwhelming, as the massive nuclear reactors operate at maximum. Engineers monitor thousands of critical gauges and valves, ensuring the propulsion systems do not fail during the most critical moments. A sudden loss of engine power would leave the ship completely at the mercy of the towering, rogue ocean waves. The captain remains awake on the bridge for days, staring into the dark abyss and making rapid, life-saving decisions. They rely on their experienced bridge crew to provide constant updates on ship-heading wind speed and radar weather tracking. Outside, on the exposed weather decks, the conditions are absolutely lethal to any human caught without a safety harness attached. The freezing salt spray hits the skin like flying glass, while the hurricane-force winds make breathing almost completely impossible. No one is allowed outside unless absolutely necessary for emergency repairs, and they must be tethered securely to the ship. The intense isolation felt by the crew is profound, knowing that no rescue helicopters could possibly reach them right now. They are completely alone in the middle of a raging ocean, relying entirely on their training and their steel ship. This shared suffering creates an unbreakable bond among the sailors, forging a brotherhood that lasts long after the storm passes. They learn to trust each other implicitly,
knowing their lives depend on the person working right next to them constantly. When the storm finally begins to break and the winds slowly subside, a profound sense of relief washes over everyone.
The violent pitching gently transitions into a rhythmic rolling motion, signaling that the worst of the typhoon has finally passed. Sailors slowly emerge from their secure compartments, blinking against the sudden bright sunlight piercing through the dispersing dark storm clouds. The flight deck is covered in thick white salt crystals, left behind by the massive ocean waves that crashed aboard. Damage control teams immediately begin conducting thorough inspections of the entire massive vessel, looking for structural cracks or broken equipment. Every single aircraft in the hangar bay is meticulously checked for any signs of damage caused by the violent shaking. The engineering department inspects the massive propulsion shafts and steering gears, ensuring they survived the immense stress without any fractures. Remarkably, these modern steel leviathans usually emerge from super typhoons with only minor cosmetic damage to their exterior paintwork surfaces. This incredible resilience is a testament to the brilliant naval architects who designed these unsinkable floating fortresses of military power. They applied the harsh, bloody lessons learned from tragedies like Typhoon Cobra to create the safest warships in human history. Today, the United States Navy operates 11 nuclear-powered aircraft carriers, projecting immense military strength across the entire global ocean. These ships serve as sovereign floating territories, capable of delivering humanitarian aid or executing devastating combat operations anywhere on Earth. Their ability to survive the most extreme weather conditions ensures they can respond to global crises without any weather delays. The newest Ford-class carriers feature even more advanced weather survival technologies, including automated stabilization systems and stronger hull materials. Electromagnetic aircraft launch systems replace the older steam catapults, providing more reliable operation even in freezing temperatures and heavy seas. Advanced phased array radar systems can track incoming weather fronts with unprecedented precision, giving the crew more time to prepare. But despite all these incredible technological advancements, the fundamental battle between man and the unforgiving ocean remains exactly the same. Nature possesses infinite energy, and the ocean will always be a chaotic, unpredictable environment capable of destroying the unprepared mariner. Respecting the immense power of the sea is the very first lesson taught to every young recruit joining the Navy. They study the tragic history of Admiral Halsey and his doomed fleet, understanding that arrogance at sea leads to death. The ocean does not care about advanced technology, nuclear power, or the massive military budget of the modern armed forces. It only respects solid engineering, meticulous preparation, and the unwavering discipline of the brave men and women sailing upon it. Every time an aircraft carrier sails into the vast Pacific Ocean, it carries the legacy of those who perished before. The ghosts of Typhoon Cobra serve as a constant, silent reminder to never underestimate the terrifying wrath of Mother Nature. Modern sailors honor their sacrifice by maintaining the highest possible standards of readiness and damage control proficiency at all times. They run endless drills, simulating massive fires, hull breaches, and catastrophic equipment failures until the responses become pure muscle memory. This relentless training ensures that when the next super typhoon strikes, the crew will react with calm precision and efficiency. The symphony of thousands of sailors working together in perfect harmony is the true secret weapon of the modern Navy. Steel and nuclear power can only do so much without the indomitable human spirit driving the massive warship safely forward. It is the courage of the young mechanic tightening a chain in the dark that ultimately saves the entire ship. It is the steady hand of the exhausted helmsman steering through monstrous waves that keeps the massive vessel safely afloat.
It is the brilliant leadership of the captain making split-second decisions that guides the crew through the darkest nights. The story of aircraft carriers battling super typhoons is a fascinating intersection of advanced human engineering and raw natural power. It showcases our incredible ability to adapt, survive, and conquer the most hostile environments on our beautiful but dangerous planet. As climate change potentially increases the frequency and intensity of oceanic storms, these incredible engineering marvels will face greater tests.
Future naval architects will continue pushing the boundaries of material science, creating even stronger and more resilient vessels for tomorrow. The evolution of the aircraft carrier is a continuous journey of innovation, driven by the relentless pursuit of maritime dominance. We have explored the tragic history, the brilliant engineering, and the immense human endurance required to survive a marine superstorm. From the deadly waves of 1944 to the advanced technology of today, the journey has been truly remarkable. The sea will always remain an untamed wilderness, but human ingenuity has found a way to navigate its darkest tempests. These steel sea giants stand as monumental achievements of human engineering, proudly defying the absolute worst weather nature can unleash. They are floating testaments to our determination to explore, protect, and control the vast blue expanses of our global oceans. The next time you see a massive aircraft carrier, remember the incredible hidden strength built into its dark steel hull. Remember the brave sailors who work tirelessly in the dark, stormy nights to keep the massive vessel and crew safe. Their silent sacrifices and unwavering dedication ensure that these massive floating cities can survive the most terrifying storms on Earth. The battle against the ocean is never truly won, but simply managed through constant vigilance and absolute respect for nature. As long as ships sail the ocean, there will always be storms waiting to test the resolve of the crew. But with brilliant engineering and unbreakable human spirit, these magnificent steel giants will continue to ride out the massive waves. Thank you for joining us on this incredible deep dive into the fascinating world of modern naval architecture and history. We hope you gained a deeper appreciation for the massive challenges faced by aircraft carriers during extreme oceanic weather conditions. If you enjoyed this detailed exploration of naval engineering, please consider subscribing to our channel for more amazing historical content. Until next time, stay safe and keep exploring the fascinating stories behind the incredible machines featured on Steel Sea Giants.